Welcome. This is the lecture. Thanks for the introduction, Nuria. I'll just briefly start with my recent journey, and I say recent because it's the last 18 years or so. But chronologically, it's been in public administration. So I get to say things about government people because I've been one of them. Then into innovation consulting, then a focus on culture change, then leadership development. Finally, on a systems level, I went fairly deep into network analysis, and now I'm concerned with systems change. But that's a linear kind of chronological order. In fact, the journey has been more that as I entered into different areas, I then reflexively understood more about previous areas that I'd been in because of new information coming in. And I'm saying that just to show that when we're thinking about kind of systems thinking and systems mapping, we want to focus on the idea of nonlinear thinking rather than linear thinking. And this kind of theme is going to come up during the presentation. My goals today are to encourage you to think and see differently, to signpost some systems concepts that can be useful in your work, to help you to understand how government thinks. So for the students, you're working on interventions in the government, and it's useful to understand how this system thinks. And to give you some weapons to see systems so that you can understand them and you can shift them. And I'm probably going to confuse you a little bit because I'm going to throw a lot of information at you in over the next hour and stuff. But you shouldn't be worried about that because this kind of sense of confusion, it's necessary before you're able to do some breakthrough thinking. It was Leonardo da Vinci used to cultivate this attitude called sfumato, which is being able to hold multiple things in your mind. And I think that's a necessary mindset when we're talking about systems thinking. This will be a play in 3 acts. So start with some meta context and mindsets, then we'll go into systems thinking concepts. It's such an enormous field that with the time allowed, I've only sort of extracted a couple of them, which I think are particularly relevant to the challenges on this course. And then we'll go into systems map and mapping. And it's worth bearing in mind, this is really a basic cursory introduction because any one of the topics I mentioned now is pretty much worthy of its own master's level course. So let's start with the meta context and mindsets. I want to locate your mind into this idea that the human project has undergone some pretty radical systemic transitions. And when we're talking about government, this is the time frame that's important. I'll go a bit more into detail, but from the industrial age through the information age to the connected age, or this time period we find ourselves in now. So if we go right to the beginning, we started as hunter-gatherers, and there's this pattern where some new technology comes up and it creates a new reality that kind of shifts us into a new age. So the plow makes us an agrarian society, then the steam engine provokes the industrial age, the silicon chip, the information age, and now we're in this connected age. There's some other terms people use for it, like fourth industrial revolution or the internet age, what have you. I prefer this term, connected age, which was largely brought about by the arrival of the internet. And we already know that artificial intelligence is the technology that's going to spurn the new age. And another thing to think about that is the timescales in which these shifts are happening. So they went from hundreds of thousands of years to tens of thousands of years down to now we're getting very fast shifts. And this is kind of important, I want to point out, because government by and large, I'll go on to argue, was formed during the industrial age. And it still has this kind of timestamp in it. So when it's trying to change things, it's still of the mindset that we have our current situation, it's not really working, we need to design appropriate interventions that'll be okay for a while. And I don't know if that's a really good idea, because now the rate of change is so fast that it's probably a better idea to now be designing for constantly adaptable states. right? Which is a big challenge to people who say, I'm commissioning a target operating model that should function for 20 years. Well, the environment is going to change so fast, it's going to be outdated before you ship it. So the ingredients that were available when modern government and public administration ideas were baked are cooked into the foundations of how governments think and behave. So in the industrial era, the best we had available was Newtonian science, linear thinking, scientific management, Taylorism. If you're not familiar with that, it's the basic idea that you separate the thinkers from the doers, right? Like management and factory workers. And these ideas are still quite predominant in the way that governments think. So if you're going to be working with governments to design new solutions, it's useful to understand kind of the context in which you're working. And I'm making some generalizations here because government is a system that's kind of like unemotional and what have you. But there are brilliant people who buck the trend within the government. And you're meeting quite a few of those as speakers in this course. So yeah, the main point here is when you're working with government, you're trying to solve challenges of the connected age with a system that still thinks like the industrial age. So who wants change? Everybody wants change. Who wants to change? Well, that's a much more difficult question. And this is where my time in the culture change fields kind of raises some interesting issues. So I want to introduce the concept of acted values versus stated values. This is actually academically rigorous. I'm not an academic, so I'm just interested in stuff that works. But acted values or stated values is what we say we'll do, what we say will be like. And acted values is how we actually are. And so the wider the gap you have between the stated values, all the things government says it will be, and then the difference with how it actually behaves, the higher the frictions, particularly cultural frictions, there will be in the system. So this is one of the perspectives that's worth keeping in mind when you're working with the government, is like what is being said, but what is actually happening, and where's the gap between that? So here I've got a list of before and after, so industrial era mental models and connected era mental models. And I put this list up because remember I said the government by and large still thinks really like, as a whole, like an industrial era kind of thing. And so for example, it's still seen as a machine metaphor. I watched the lecture of the previous speaker on policy, and she actually used the phrase, the machinery of government. So this is the kind of language that's used, and it reflects the attitudes that are, that have been like kind of contained within the current operating parameters of government. So we live in a society in which these kinds of ideas are available and desirable, and we understand that they offer kind of new opportunities, but we're governed by institutions that are still pretty much kind of in this sort of area. And the gap between those makes interventions in government very difficult. And I think as a designer working on a government problem, you need to hold this in your mind and say, hey, let's find some interoperable solution, but bear in mind that we're offering that to a system that's still thinking in a very much sort of proprietary way. And I'll do a little bit on structure of government. So basically there's two parts. There's policy, where the intent or the politicians get elected on a particular mandate, and that's the policy intent. And then there's other parts of government which deliver action plans and strategies to make that happen or possible. Within those two layers, you've got other substrata. So the politicians, the senior leadership primarily operate at this kind of level. Then you've got the management layers, which sort of straddle the two. And then you've got the frontline workers, delivery teams, services and things like that that are primarily focused on delivery. In addition to that, you have these kind of vertical silos of the ministry, so defense and health and social and healthcare. and what have you. You see my machine emerging here. Between these gaps, both these horizontal ones and these vertical ones, there are cultural air gaps. So politicians are a certain way, have a certain language, do certain things. Senior leadership have their own sort of microculture. Management is another one, and the frontline workers is another one, and also between the different ministries. So like the culture in the health ministry is very, very different to the culture in the defense ministry. And these gaps, it's kind of like a result of the scientific management and Tayloristic thinking of the industrial age that were structured in this way, and it has created consequences that create difficulties in the boundaries about, like communicating in a similar way. So we need to be aware of those when we're trying to make a systemic intervention. And normally, an issue, a policy issue, is kind of historically and normally contained within one ministry. So the policy is made up here, then the strategy and the action plans happen here, and then it's in command and control system, it's kind of put to the front workers to deliver. So a single silo area, policy areas. More recently, when you think about the idea of phenomenon-based policy making, you might have a policy area that straddles two different ministries, and there might be some connections here at the senior leadership level, and then the instructions are cascaded down, and maybe you see some engagement between frontline workers. If we want to take a systemic view of government and policy, then a complex-based intervention might look something like that, where many different ministries are involved at different levels. There are different kind of links of coordination, and the delivery of the services involve frontline workers from different ministries coordinating well under some kind of management. This is kind of the future that we're hoping to get towards, but using the application of systems thinking. But we're pretty, bar some isolated examples where we're starting to see the possibility of this, we're not quite there yet. But I think if you want to take a systemic view as a designer, this is the kind of way, this is the kind of future you want to envisage and you want to be working towards. So that's the beginning session. How am I doing for time? Yes, okay. Part two, I'm now going to dive into some systems thinking concepts. Again, a kind of a selection of things that I think are particularly important to people who are working on a design brief for government. So if you've read Donella Meadows, you might recognize this is my version of words, very simplified, but system is just a defined collection of things that are connected by relationships that together as a whole have some kind of a purpose. So like a bicycle is a collection of wheels, seat, handlebars, frame, with relationships like chains, and where the interface with the human is the seat, and things like that. And it's got a purpose to move weight, mass somewhere. So at a simplest level, that's what a system is. It's things, it's links, and it's got a purpose. What kind of system are you looking at? So here we introduce the Cynefin framework by a chap called Dave Snowden from Wales, where I used to live. And this is a highly simplified representation, but he basically says, when you're looking at a system, it can be simple, it can be complicated, it can be complex, or it can be chaotic. And depending on what the system you're looking at is, there's a different kind of approach that you need to take in order to make interventions in that system. So a simple system like a call center transaction is simple, and the approach is sense, categorize, respond. So if I call the call center, they'll ask me some questions, like give me 4 options. They'll sense what my input signal is, and then they'll categorize it. Oh, I pressed 2 on the robot button. It means that I want to open a bank account. And then they'll respond by putting me through that particular funnel. A complicated system, something like a bicycle. So if there's I'm riding it and it starts wobbling and stuff, so there's a problem with it. I analyze it that the tire is flat, and my response is to change the tire or fix the tire. When we move into the complex area, like a government institution, the way that we respond our interventions is a little bit different. So we probe. So let's say that you've got a policy intent. You design some kind of intervention. So you probe, and then you see if that kind of works. If the action that you've prescribed is giving you the results for the policy intent that you want, and then you respond. That's this kind of like you quite often see things like pilot programs being done. That's a probe, right? You're sensing the response before you put a lot of.
Esko, could you please close the toolbar?
Oh,
it's
is it
in
still
the way
there?
of, yeah, there we go.
Ah, okay.
And this one maybe.
Can you see that one as well?
Mm-hmm.
Oh, how awful. Okay.
There we go. Thank you.
Thank you. Sorry about that. Yes, so like complex is like a government institution, and then the chaotic is, we recently had a really good example, the global pandemic, and there the sequence of intervention is you act, you sense what happens from that action, and then you respond. So for example, in Finland, in the first lockdown, it was noticed that most of the cases were in Helsinki, so the government put a ring of steel around Uusimaa. They acted, and then they check, they sense, see like, is this effective? Actually, even with that intervention, the spread of infection went beyond the iron wall. So now we're seeing in the new lockdown that's coming up, or heavier restrictions, the response is in some way informed by what we sensed from the first action, kind of thing. So point of this is, when you're looking at a system, first make sure that you understand or you locate it within one of these categories, and then that informs a little bit the sequence in which you should think about your intervention. Feedback loops, absolutely basic fundamental concept in systems thinking, and a lot of the other more kind of like elaborate stuff is necessitates an understanding of feedback loop. There's two broad categories: that reinforcing feedback loops, and that's like the more you get, the more you get, the rich get richer. So a basic example is money in bank. You get more interest you get, more money in the bank. Balancing loops or negative feedback loops are quite interesting, actually. So basically, like simple example is a temperature in the house and the thermostat. So and what's really important to understand about balancing loop is that they have a goal, right? They have a designed goal in mind. So the goal of this particular balancing feedback loop is to maintain the temperature constantly. So if it goes up, there's a signal to the thermostat and it turns down the heating. And if it goes down, there's a signal to the thermostat and it turns it up. A minus doesn't mean less of, it means opposite in feedback loop terms. And I want to point this out now because when we go to look at intervention points, I'm only briefly going to describe it because Andrea is going to do a full lecture on that later in the program. But because negative feedback loops have a goal, there's this idea in the intervention points to change the goal of a system, right? And changing the goal of a system is very high impact intervention point, and changing the goal of a balancing feedback loop is a very low impact intervention point. And that's where most of the sadly, like the regular interventions are operating kind of at that level. Like, can we just change the goal of the feedback loop? And then something positive will come out of that. Emergence, this is my favorite one. So you're all familiar with this kind of like self-organization of a group of agents that only obey a certain amount of rules. So emergence occurs when an entity is observed to have properties its parts do not have on their own. Properties or behaviors which emerge only when the parts interact in a wider whole. If we go back, like, let me do a little sidebar to industrial age thinking. So if I'm a manager in an industrial age mindset, I have a bunch of resources at my disposal. And usually when I have a new goal, it's a question of reorganizing those resources in a way that meets my new goal. When we're thinking about systems, we're also looking at the relationships between things. And I've a bit lost my train of thought on that, but in order to get to emergent behavior or novel behavior, it's more than just the sum of the parts. It's when you connect things in new and novel ways, and you look at the relationships between those, like you're intervening in that, you can emerge new behaviors that are not possible without that particular configuration. And for the students, if you watched the Nikki Case video I recommended, you will recognize this idea of selection and variation. For the dial-in guests, you probably won't have any idea what I'm talking about. Maybe we'll put a link for that in the video recording. But emergence essentially is composed of two areas: selection, which is a combination of positive feedback loops and balancing feedback loops, and variation, and that's composed of the density of the network connections and chaos. Now, let's try to link that a little bit to thinking about government. So government is almost entirely made up of positive and balancing feedback loops. So command and control hierarchical bureaucracy can essentially be broken down and defined by these are things that we're intending to see more of, and these are corrective actions to reduce conditions that we don't necessarily like. So law, policy, all of that kind of stuff, it's essentially you can describe as different kinds of feedback loops. Variation, this is like the creative side of things, requires a dense network of connections. Now, the structure of government, as I talked about before, actually works against dense networks of connections. It kind of like contains things within particular clusters, and because of those air gaps that I talked about, it kind of encourages against, traditionally, historically, this is changing a little bit, but connections forming between the different silos. So first enemy of emergence from government is the structure of it. And then the second thing is chaos. So there are few words that freak government people out more than chaos. Like they like things like predictability and stability and regularity, things like that. Chaos isn't a dangerous word. If I go back to our birds here, there's a couple of feedback loops happening. So if you want to understand like how self-organization works, each dumb agent follows a couple of simple rules. So for example, if the bird to the left of me is turning a bit that way, I'm going to follow it. Or if the one if they start moving to the left, I'm going to generally follow the pattern. That's just a simple rule I have to follow. It's a balancing feedback loop. Dense network of connections, they come together, and the chaos element is they only do this when there's a predator in the air. So that's the chaos element of that. So for emergence, we want to understand the kind of feedback loops involved in the systems that we are. What are the network connections, how dense they are. Later in the systems maps, I'll talk about networks a little bit. And then chaos, or you might, if you want to make it a little bit more friendly to your government sponsors, like call it creativity or something, but introducing an element, a novel element into the system that kind of provokes a shift in the feedback loops in some way. It's quite a heady concept. I'm like 3 years now learning about emergence, and I still can't quite well define it to people, but it's a key aspect of systems thinking we need to think about. Let's talk a bit about systems, elements and attributes. Remember from the definitions, it's a bunch of things and relationships. So in network terminology, those things are called nodes. And they can be different things. They can be tangible or abstract. So nodes can be, in your system consideration, people or organizations, documents, associations, other networks, transport, so stuff. And then the relationships can also have different characteristics. And when we get into the systems mapping, this is really key, because most systems maps you will have encountered, you see a line between two things. But what does that line mean? What is the data contained within that line? That's where the magic happens, when you understand really what's going on in the relationships, rather than just having a bunch of stuff that you can reorganize. So links can be relationship, physical, contract is a link between two people, decision flows, communications, knowledge transfer, things like that. So here's an example, and the nodes also can have attributes within them. So Alice as a node, as a person, has a gender, an age, a location, a team, KPI performance score, time served, whatever. We can encode information about this node in a variety of different ways, as we can with the links. So let's say there's a node called Bob, and there's a line between Alice and Bob. So at first glance, we can infer that they have some kind of a connection, but what is that connection? Maybe it's she's his manager, or she communicates with him, or she needs to approve the decisions that he makes, or she provides him technical support, or they socialize, or she gave COVID to him, things like that. So in your mind, as you get to the point where we're going to start looking at your problem space, is to start thinking about what is the information that's relevant in that line between these two things, that gives me a deeper understanding and gives me opportunities for novel interventions. Unintended externalities. This is core concept. So remember, from the industrial age, we're primed for linear thinking. So we say, here's our problem, here we do our intervention, here's our solution, and we're happy or we're not happy. And it's completely blind to all of the other things happening around it. So Peter Senge tells a really neat story. Actually, I first heard it when he gave a lecture at Aalto some years ago. But he's talking about how the highway designers in California in the 1940s and 50s, they had a goal to kind of design a system that would enhance the mobility of people through Los Angeles. If you go into the history, they were actually fighting against the monopolistic railway operators. But so their goal was like, can I create a system that allows effective mobility for economy and all this kind of stuff in Los Angeles? And the predominant mindset at the time is that the automobile, the combustion engine vehicle, is kind of the thing that we have to design for, because that's what's here now and what's coming. What they did not have in their design brief is, let's create a pollution problem that obscures visibility and creates health concerns for all the problems. But the consequence of their design actually created that problem. And when you're taking a systems view on doing on working on a government challenge, if you're contained within the silo or the parameters or the obvious kind of boundaries of your problem area, you develop blind spots to the kind of consequences that your intervention might create. So in a systems thinking view of approaching that, we want to cultivate our awareness of the potential impacts of our interventions beyond the immediate question for consideration. This is maybe not strictly a systems thinking concept, but I think it's pretty fascinating and useful anyway. Yeah, let's go with it. So pace layering comes from Stuart Brand from the Long Now Foundation. And essentially this diagram is showing that in the progress of a civilization, there are different elements of that progress that work at a different pace. So fashion is very, very fast. Infrastructure takes a lot more time to kind of plan and acquire resources and develop and stuff. And things like culture and nature have a very slow development pace. So try to visualize like this is a clock and the second hand is moving. And for every second that goes at the nature level, down here, there's a very slow increment. But when you take it to the faster layer, the fashion layer, it actually travels quite a long distance. Yeah. And I think this is an interesting mental model to hold in your mind, because first, when you're doing a design intervention, it's useful to locate like at which level is this kind of operating, and then to think about like, if I take a lot of effort to move the commerce part. So one of the projects is about procurement with respect to the maternity boxes here. So that's maybe located in the commerce sort of layer of things. The amount of travel that you have to make to do an intervention corresponds to a fairly small culture shift, maybe, or governance shift, a slightly larger one. But what if you flip it around and you say, my project, my kind of goal, my intervention zone is located here, but what if I find something in the culture that I can move a little bit? And then how much bigger impact can I have across these other layers? So I think this is kind of interesting. When you're looking at your problem, have a consideration of, is there at some other layer where I can make the intervention that's going to have a bigger impact for minimal resources in one of the other layers? Okay, leverage points. I'm not going to go into detail about this because it is the subject of a next section, but I can't not mention it before we look at the system mapping stuff. So essentially, there's different areas in which you can intervene in a system, and the ones on the right-hand side are much higher impact, and the ones on the left-hand side are lower impact. Sadly, and I think as a consequence of the industrial era mindset, most of the government work and interventions are actually operating at that kind of lower level. And so the challenge for us is, how can we break out of those patterns and try to move our thinking up into the higher dimensions? And remember, when we were talking about feedback loops, I said negative feedback loops, they're characterized by having a goal of their own. So changing the goal could be here, but also if you change the goal of the system, that's a much higher level intervention. So we'd rather be doing things there. And structure of the system also, I think, is interesting given what we're about to talk about, system maps and things like that. But Andrea is going to join, is it next week or the week after, and cover this in more detail. Here's a quite fresh one. So Charlie Leadbeater, who I met about 10 years ago on my innovation journey, has written a very fresh paper this year, or maybe it came out last year. And there he suggests that if you want to shift a system, there are 4 keys that you can pay attention to, or you need to pay attention to. And that's purpose, power, resource flows, and relationships. So we know that systems are things and relationships. And in the relationship category, I think that's reinforcing the idea I said earlier that the magic is in the relationship. So you want to have like a really high definition understanding of what's going on there, which direction it's going, the attribute data. Purpose is why does this element, what is the purpose of this particular element? Is there an opportunity for me to redefine that in some way that triggers a pretty dramatic shift in the system that I'm looking at? Power is just, I mean, government is the raw exercise of power. So understanding where power is located in the system and how it exerts its influence on other part of the systems, kind of a key criteria to put your mind to understanding in the system that you're looking at. And then resource flows. That's again kind of a combination of some elements have resources and give them to others, and that can be like money or materials or mandate or what have you. Take a wide definition of resources, and then understanding how they flow in the system, and can you reconfigure those flows? So, for example, I'll talk about networks in a moment, but that's one of the strategies available for systems interventions, is kind of diverting resource flows in other directions where they're more helpful. And there's a link there. Please read his green paper. It's very exciting. And that one, I've failed to mention Frank Gale's model, which is fairly potent in systems thinking circles and stuff. And he references it quite well in that. So I do encourage you to go and read that paper. He actually iterates on the Gale's model into what he calls the washing machine model. So please do read that link. Right, cracking on. Yes, I think the time is okay. Let's go into systems maps and mapping. So here's a bunch of different kinds of systems map. Up here, we've got rich pictures. I think I've lost my little laser pointer. Can you see my mouse, Nuria?
Yes.
Okay, yeah. Up here, we've got the rich pictures. This is a kind of generic systems map. It's made by Tobias Temmen of the Systems Innovation Community, and it's a map of the financial system. And maybe later on during the exercises, I'll show the students the actual live map and what you can do in terms of filtering and identifying subsystems and stuff. This is a typical example of a causal loop diagram. You can spot them because they have little minus signs and plus signs, and then this kind of equal sign indicates a pause in the flow of things. This is a social media data derived map of a Twitter conversation. This is one I made. This is actually a government institution. I'll talk a little bit more about that. These are giga maps, which the complexity and design community intersection. They hang out at a conference series called Relating Systems Design, and they're really into giga maps, which are quite good at kind of combining multiple different types of subsystems into one visual representation, the relationships between those. And this is, I guess, a generic system map, but this is the map of Afghanistan created by Stanley McChrystal, and it's often used as an example to show like how completely unusable system maps can be. Like if you're, a captain of some military unit in Afghanistan, and that's your kind of, what do you do with that? So it's often used as an example of how not to show things in a useful manner that you can make intervention. And here I'm breaking all the rules by just showing you without any labels a systems map of a government institution that when you look at it, it's like a hairball, doesn't make any kind of sense. But when we dive in with graph theory, analytical metrics, and we start filtering and putting labels on, we can make sense of very interesting things that are happening within that map. So you've got a wide range. There's some others that I'm not familiar with. I'm not going to pretend to but other brands are available or types are available. So yeah, as I've described, generic system maps, it's things and their relationships. Rich picture is a system that's quite good for first attempt at mapping. It's easy to get started and make preliminary sketches. Causal loop diagrams are kind of good if you're interested, if your situation requires you to go towards predictive modeling, so finding out what happens in the system when you raise a value or lower a value. The gigamaps are good for showing interactions between multiple subsystems of different types. And my favorite, like this is my comfort zone, network maps. One thing that they can do is they can show system change over time. And if you've got your data kind of optimized for a graph model, then you can start, and your data collection is good enough, then you've got a suite of really powerful analytic tools. So like, finding influencers in systems or mathematically determining the communities within a system. So of course, I'm totally biased. I think probably if you're starting on the journey, go with rich pictures. But eventually, if you want to do power systems mapping, then get interested in network mapping. So what are these systems maps for? The first step, it's for understanding a system. As you get kind of like more information into your map, and this is definitely an iterative process. You will never start with a goal, make a system map, and it be ready to be useful. You'll start with your first idea of it, and then find the limitations and the missing things and the extraneous things, and then iterate that design. And as you do that, it's actually the process of cataloging things and their relationships and what those mean that you come to understand your system. Then they become a sense-making tool. So once it's refined enough to like extract meaning from that, start using it as a sense-making tool. And a generic system mapping process is you collect information, you map it, you find leverage points, and then you design interventions for those leverage points. Any kind of system mapping process basically uses those phases. So once you've got enough information and you're deriving some kind of like insight from that, you're starting to emerge the places in the system that you can intervene. And then further than that, when you're talking to your stakeholders or you're trying to present this information like to the public or justify the expense of your commission and your intervention, it's a storytelling tool. And at that point, like that's an entire discipline of its own, because showing people a hairball or like that Afghanistan map, it doesn't tell a story. It presents information with such a high cognitive overload that unless people are familiar with the process that arrived at that, it doesn't tell them anything. So the storytelling part of that is, how do you isolate subsystems of your greater system in order to tell a very specific story that helps somebody understand to make a change or do some intervention. Okay, we're racing towards the end here. Very important thing to think about is system boundaries. So system is basically defined by where you draw the circle around it. When you do that, you make a choice. You're saying, I'm including some things and I'm excluding other things. And the biggest mental failure that you can have is once you have made that decision, is to think that the world outside that boundary doesn't exist. Because your system, by nature of having made a decision about the boundary you put around it, is just a subsystem of a wider system. So, for example, in Nuria mentioned doing a project on eliminating human trafficking and studying how to do systems map of that. We have decided to put a circle around Finland. We're looking at the problem in Finland, but human trafficking, people are supplied from outside of Finland. So by necessity, we have to hold in our minds things that are happening outside of our defined boundaries. And a useful thing a way to think about it is where you've defined your boundary, you're going to go really high resolution. I want absolutely all of the information that I can include about the system within the boundary, but I will maintain an awareness of the systems beyond the boundary at a kind of a low resolution. And this is also when we talked about unintended externalities. This is absolutely key. If you become myopic within your system boundary, you are going to cause problems for people outside of it. And there are going to be things like black swans that come into your system that you weren't aware of. So I think this is quite, the boundaries are a choice, they're an abstraction, and think of them as permeable. Maybe at some point in your process, you need to redefine that boundary because you were excluding, like you were creating a blind spot by excluding something which actually you can't get away from. It's direct influence on your particular system. And this is, so in 2017, I gave a talk at a keynote at the Service Design in Government conference, subtitled "Fiddling with the Aqueducts While Rome is Burning." And this, I'm saying this in relation, so basically, when you get a design brief from government, they've already parameterized it. You know, they've defined the system boundary. And so your focus goes into those elements that they've described. And it is their brief, and that's the thing that you need to look at. But if you get system boundary blindness, then it's possible that, well, it's likely that you will fail to spot opportunities at higher level intervention points, and you might be working on the wrong problem at all. So most briefs are about, like, can we increase the, can we reduce the time of a citizen transaction, or can we reduce the cost by €2 of a systems transaction? But if you're bearing all your skills on something like that, while in fact beyond your entire government system is trending towards fascistic tendencies, then are you actually, like, what's the point? So that was an appeal in 2017 in the UK. I guess you guys read the news and you can see sort of the trend that's going. Are you kind of like blinded by the parameters of your brief that you don't understand that somewhere else the really urgent kind of design intervention is needed? And so as you go through your design process, and the designers amongst you will recognize a similarity to the shape of the double diamond, but basically you go through phases of accepting new possibilities or creating different possibilities, and then you get the state of confusion where you don't know what to do anymore because there's too many choices, and then you have to make some choices to kind of converge down to a particular thing. This is very similar when you're doing system mapping. Is first you want to include a lot of things, and then it becomes unwieldy. Then you have to make some hard choices about defining system boundaries, and then you can focus down. But this should be like an iterative process. Don't go too convergent without every once in a while going back to sense check. Like, do we now actually need to reintroduce the idea of divergent thinking and reconsider our system boundaries, which will cause confusion. So I guess it's a short way of me trying to say that, like, it's a non-trivial, hard process, but you have to go through it in order to get good interventions. Running through, I hope we'll have, I think we'll have time for some Q&A also. Okay, network maps. This is a real government organization. I mapped it myself. And it looks like a hairball, but what this representation is what contrast that to, you all know in your mind what an organization chart looks like. It's a system map because it's got elements and relationships, but all it really tells you is who works for who, or who's your manager, right? And if you're an industrial era mindset organization, it's going to look like a stovepipe, command and control ladder hierarchy type of thing. And that is the low resolution image that a lot of people make very expensive decisions based on. But the actual reality is that an organization is a complex system with multiple types of relationships, and this is what it really looks like. This is a composite that includes things like who's your manager, but also who talks to who, how decisions get made, and how resources flow through the organization, and how technical support happens, and how social support happens. Like, it's a proxy for trust, really, who's trusting who within that. So network maps or systems maps should, in my opinion, be complex representations of the system that you're looking at. They should factor in multiple different categories of relationships. And then when you have that information, so like, imagine this is how communications work, this is how decision making works, this is how resource flows work. And then with the composite, you have a much richer picture of what is really going on. And if you happen to put it in a network map, then you've got a suite of super powerful analytical tools that you can look at. So I guess the point of all of that was, as you're doing your system maps to understand your problem, you're not just doing one. One of the choices you have to make is, what are the different dimensions that are relevant to this problem space? And that, how do I get the information that includes that, so I get a full picture of it? And finally, when we've got our storytelling map, when we've got our system map, we'll want to, let's say we've identified our intervention point, we want to go back to the customer, or justify to the government customer, or justify to the public what interventions we're doing and why. And this, again, it's a little bit biased towards network maps and network thinking, because that's my comfort zone, but I think it's quite useful that there are three main perspectives that you can use for the storytelling. The first is the topography, or the story of the structure. And there you can say things like, remember when we were looking at Emergence, we were saying that the density of the network connections is quite important for emergence to happen, novel solutions to emerge from combinations of resources. So when you look at a system map, like if there's lots of links between lots of different nodes, you can see that there's a high density, and you can also mathematically determine that. Or you could see that it's really fragmented and clustered. So then you could say, like, hey, government client, one of the issues that's preventing you from delivering on your objectives is that the topography of your network is actually far too undense for it to be effective. So that's interesting. The other perspective is the individual perspective from the story of a node. So imagine I'm one element within a very complex system. The other nodes that I'm connected to, that's what I see. That's my experience of the world. There are other things going on beyond with other those nodes have other relationships, but what I see is the things I'm connected to. So you can kind of isolate a part of the system and tell the story of what's going on here in that particular area. And then the last perspective of story is the story of a journey between two nodes. So let's say there's a resource over here and there's a demand over here, but structurally they're not connected. Can I show through the map like the collection of links that establishes a path between this resource and this need? Those are the three main ones you can look at. And again, because I mean, like there's, when you have your information and you start to identify your leverage points, there's a couple of classes of intervention strategies that you can look at. The most exciting ones are engineering at the relationship level. So can I change the nature of a relationship, or can I divert it between other nodes, or can I add value into a particular attribute or parameter. Other one is create links that are missing. So for example, if there's a really long path between a resource and a demand, can I create a link that ties them directly? Can I remove links that are unhelpful? This is kind of, if you want to destroy terrorist networks, that's the strategy that you use. Can I designate a specialist role to a node? So a node has a particular function. What if I change the function of that? And then when we look at the similar but slightly nuanced different is, can I change the purpose of a node? Remember the 4 keys? One of them is purpose. Can I affect a system shift by changing the purpose of a particular node in a helpful direction? Okay, that's it.